All right, kiddos, peeps, whatever you want to be called. We're going to continue reviewing some IM1 stuff, and today we're going to talk about solving multi-step equations. But first, I want to really get into something that I think myself and I believe students here at Chafee are not really aware of, and it's this part here. When we get a math answer or a problem and we get and find the final answer, we got to make sure that the answer we get or the number we get actually makes sense in regards to the problem. A lot of times we'll get an answer and we'll just put it down as the correct answer, and if you really understand, it probably doesn't make sense to what the question was asking you. For example, if I asked you to find how many miles McDonald's is away from Chafee, and your answer came out to -4, well, you can't really have -4 miles. So -4 would not be a reasonable answer. So one thing I just wanted to show you here is go ahead and, when you get an answer, you always want to try to figure out in your head, like, what should the answer look like? Should it be positive? Should it be negative? Is a fraction okay to have an answer? Okay? So we have these little bullets here. We call it GSR. You want to kind of guess an answer, like I said, an idea of what type of answer you would have. Then you're going to solve the problem using the mathematical method. In this case, we're going to solve equations. Solve the problem. And then you want to make sure that the answer you got to your problem is reasonable. If it's not reasonable, you might want to go back and double check if you did something wrong or you did something incorrect mathematically, and then go from there. Okay? So if you look at this here, example A and B is just some ways of using or incorporating GSR into a certain problem. So if you look at example A, it says, would x equal 3 be a good guess? Why or why not? So again, you don't have to write it down, but I just want you to think about that. Why would x equal to 3 not be a good, or would it be a good answer for example A? So pause the video if you want to take some time to think about that, but this is what I'm talking about when we talk about GSR. Why would x equal to 3 be a good or a bad answer, or a bad guess or a good guess to example A? Same goes for example B. If you had to guess, would x be more or less than 1? So again, it's just a quick way to look at this and start practicing the acronym GSR. Guess an answer, solve the problem, and check if your answer is reasonable. All right, let's get started. We're going to go ahead and start solving for linear equations, and this is going to be very useful as you start getting into deeper IM2 stuff, and especially in IM3. So I really wanted to start here with the goal. When we're solving an equation, our goal is to isolate the variable on one side of the equal sign. So that means we want to get x, or whatever variable we have, on one side of the equal sign, so it looks something like this. We want x equals our answer, or it also can happen backwards. We can have our answer equal to x. But essentially, we just want x and an answer, or an answer equal to x. And that's our goal. Isolate just means to get by itself. To accomplish this goal, we got to take these steps into consideration. So I'm going to explain these steps, and then we're going to do these steps in example C, and then example E. All right, so the steps, the D stands for distribute. You want to distribute if you have parentheses. So if you see parentheses, use the distributive property. You should be comfortable with that. After you distribute and get rid of the parentheses, you want to do CLT, combine like terms. Okay, you should be comfortable with that. We talked about that already. It's an IM1 idea. After you combine like terms, the next thing you want to do is, if you have variables on both sides of the equal sign, as you will see in a couple of examples, you want to move the smaller variable to the bigger variable. So again, you want to move the smaller variable to the other side. Keep in mind, when you do this step here, when you're moving the smaller variable to the other side, you're going to do the opposite operation. So if it's positive x, you want to make it negative x, subtract it to the other side, and vice versa. If it's negative x, you want to make it positive x. Okay? Or you get what I'm trying to say. So we move on. Once you get the variables together, we want to go ahead and do A. This is where you're going to start doing the add or subtract to the other side. Okay, so this is where you moving anything that's adding or subtracting. Again, our goal is to isolate the variable. So if there's something adding to the variable, we need to subtract it to the other side. If there's something subtracting to the variable, we need to add it to the other side. And lastly, to the last step you want to do when you want to isolate a variable is you want to multiply or divide to the other side. So you want to multiply or divide. And if you follow these steps, you should be able to solve any type of linear equation. Okay? So we're going to do example C. I'm not going to guess here. I'll leave the guessing part for you. So if you want to take a guess before you do this, go ahead. Again, this is just trying to incorporate the GSR here. Can you make an educated guess on what our problem should be, our answer should be? Okay? But I'm going to go ahead and do the steps for C. So the first thing I want to do is I want to distribute. So I'm looking for any parentheses here. There's no parentheses. So I do not have to distribute. We can skip step 1, I guess you would call it, which is distribute. Then I'm looking for combining like terms. And when I say combine like terms, I want to combine like terms on one side of the equal sign only. So if you look here, I just want to combine like terms on the left side. So there is no like terms. Remember, like terms are, they have to have the same variable to the same power. 5x is not the same like term as 10. 10 is a constant. Okay? Once you try to do combine like terms, we go to the right side of the equal sign and figure out, do I have any like terms over here on the right side only? And the answer is no. There's no like terms with 40. 40 is all by himself. Okay? We can now move on to M. We want to move the smaller variable to the other side. So if you notice, there's actually only one variable here. So there's no variable to move to the other side. We don't have to do that. If there was a variable on this side, then that's when we want to start deciding which variable goes to who. But in this case, example C, there's no variable to move to the other side because there's only one variable, x. All right? And then now we're going to start isolating our variable. So to start isolating, our goal is to get x all by himself. So to do that, the first thing we're looking for is anything that is adding or subtracting, anything that's adding or subtracting where my x is. So if you look at 5, 5 is actually multiplying to our x, so he's not adding or subtracting. And then we look at this number. 10 is actually adding to my x, or adding. So I need to get rid of the 10 first. So we're going to get rid of 10. And to do that, we do its inverse operation, which is negative 10. So we're going to subtract 10, and we do it to both sides. What you do to one side, you do to the other. Okay? And what this essentially does, it moves our 10 from one side to the other. Okay? So this positive 10 and negative 10 cancel each other out, and we're left with 5x equal to 30. Okay? So now we check. There's nothing else that is adding or subtracting that we have to move. Now we move anything that's multiplying or dividing next to our x. And as I mentioned before, 5 is multiplying our x, so we are going to move 5. To move 5, since it's multiplying, we do the opposite of multiplication, which is division. And what I do to one side, we do the same thing to everything on the other side. So that cancels out, and we have x equal to 6. And x equal to 6, x is by itself, isolated, therefore this is my final answer. Okay? All right. I'm going to go ahead and run through example E, and once I'm done with the example E, I want you to go ahead and try D and F. Okay? So let's do this. I'm going to first get rid of parentheses, distribute. So I need to distribute the 2. So I'm going to multiply in the 2. That gives me 2x plus 6 plus 44 equal to 90. And then there's no more parentheses, so I want to combine like terms. So the like terms that I have here are 6 and 44. Okay, they're both constants, so positive 6 with a positive 44. That gives me 2x plus 50 is equal to 90. Now I move on to M. We want to see, is there any variables where I have to move together? So is there more than one x on different sides of the equal sign? So if you look, I have an x on the left side, but no x on the right side of the equal sign, so I can go ahead and skip step M. I'm going to step A, which is I'm now going to start isolating my variable. So I want to isolate my x. And to isolate my x, I'm getting rid of anything that's adding, subtracting. To do that, we do the opposite of whatever is happening. So we're adding 50. I'm going to subtract 50. Okay? The 50s cancel out, and I'm left with 2x equals to 40. And now I want to go ahead and isolate the x again. So I have to get rid of the 2. The 2 is now multiplying or dividing. This 2 here is multiplying, so to get rid of it, I have to divide it to the other side. Okay, and we get x equal to 20. Hopefully this quick review helps. Go ahead and pause the video, and I want you to complete the rest of the notes. So you're going to do problem D, F, and then G, H, and I down here should be review. Okay, so I want you to try G, H, and I.